In earlier classes, you have read that matter is composed of tiny particles called molecules. A molecule can exist freely in nature and it possesses the properties of matter. It is very small in size, nearly 10 to the power minus 10 meter, that is 1 Armstrong. ठीक है? 10 to the power minus 10 meter is 1 Armstrong. Chapter 1 में भी हमने पढ़ा था. ठीक है? And cannot be seen even by a microscope. They are seen only by electron microscope. The molecules are in motion as well as they have the force of attraction among themselves. Due to motion, the molecule have kinetic energy and due to forces of attraction, they have the potential energy. क्या क्या रहता है इनके पास? Potential energy. हाँ. और kinetic. और force of attraction. Due to motion, they have kinetic energy. Due to force of attraction, they have potential. Force of attraction, they have potential energy. ठीक है? इसको अंडरलाइन कर लो ना. This all due to motion they have kinetic energy and due to force of attraction they have potential energy. ये वाला लाइन. Due to motion, molecules have kinetic energy and due to force of attraction, they have potential energy. Okay. The solid state would have greatest potential energy and least kinetic energy. The gaseous state, on the other hand, would have the least potential energy and greatest kinetic energy. The gaseous state, on the other hand, would have least potential and greatest kinetic. So basically, solid, liquid, gases में potential और kinetic कैसे होता है? So solid में potential. Solid, हाँ. Liquid होता है, kinetic भी होता है. And gas कम होता है. Potential energy, kinetic energy, क्यों होता है? Potential energy maximum, kinetic energy least. ठीक है? गैस में potential energy least and kinetic energy maximum. और इसमें दोनों क्या होते हैं? Intermediate. Is that okay? Yes. When a substance absorbs heat or a substance is heated, the motion of its molecule becomes rapid, so their kinetic energy increases. When the substance is cooled or it gives out heat, the motion of its molecule becomes slow and so their kinetic energy decreases. The total kinetic energy of molecules of the substance is called internal kinetic energy. इसको अंडरलाइन कर लीजिए. And total potential energy of the molecules is called its internal potential energy. So total kinetic energy of the molecules is called kinetic energy of molecules is called total internal kinetic energy. Right, total KE of molecules implies internal KE. Total PE of molecules, internal PE. Total PE of molecules implies internal P. Is that okay? And internal K plus internal P is equal to internal. The sum of internal kinetic and internal potential energy is total internal energy or heat energy of the molecules. Total internal energy or heat energy. Okay. So thus heat is internal energy of a substance. Heat is internal energy of a substance. It is measured in unit joule symbol capital J. When two bodies at different temperature are kept in contact, heat flows from body at higher temperature to body at lower temperature. The average kinetic energy of a substance is a measure of temperature of the body. ठीक है? Average kinetic energy of a substance is measure of temperature of the body. ये अंडरलाइन कर लेंगे हम लोग. Average kinetic energy of a substance is measure of temperature of the body. ठीक है? When there is rise in average kinetic energy of molecules of a substance, its temperature increases, and if there is fall in the average kinetic energy of the molecules, average kinetic energy of the molecules of a substance, its temperature decreases. However, during the change in state of the substance, क्वेश्चन 2 के लिए जिसमें हमको स्क्वायर रूट फाइंड आउट करना है 264 का उसका वर्किंग भी दिखाना है. When there is rise in average kinetic energy of molecule of a substance, its temperature increases, and if there is a fall in the average kinetic energy of molecules of substance, its temperature decreases. However, during the change in state of a substance at a constant temperature, there will be no change in average kinetic energy of its molecule, as explained later. ठीक है? When there is change of state is going to take place or is taking place, the average kinetic energy of the particles do not change. ठीक है? What changes is their potential energy. That means their force of attraction decreases, their intermolecular spacing increases. ठीक है? Therefore, potential energy increases. ठीक है? Effect of heat. Heat produces mainly the following three effects: change in temperature of the body, change in state of the body, change in size of the body. So heat has three effects on any body. It is going to change the temperature, it can change the state of the body, it can change size of the body. Is that okay? Yes. Change in temperature of the body. When a body is heated, its temperature rises, and when it is cooled, its temperature falls. The change in temperature of the body depends on the following two factors. When a body is heated, its temperature rises, and when it is cooled, its temperature falls. The change in temperature of a body depends on following two factors. First, quantity of heat imparted or rejected from the body. Effect of heat. There are three primary effects of heat. Sir, the body has a हाँ body कोई भी body, human body or material body. Effect of heat on a body. Number one, change in temperature. दूसरा, change in state. तीसरा, change in size. Quantity of heat imparted to or rejected from the body. So the next thing is change in temperature depends on what factors? Quantity of heat. It depends on number A, quantity of heat imparted to or quantity rejected. Of heat imparted or rejected or rejected from the body. From the body. Second one is material of the body. Material of the body. Okay. See यहाँ पर expression जो होता है ना इसको quantitatively भी हम देख सकते हैं. If heat supplied is Q, M is the mass of the body. ठीक है? M into S into delta T. This is change in temperature. ठीक है. S is the specific heat capacity and it depends on the material of the body. Material of the body पे कैसे dependent होता है? S के through. Specific heat capacity. Specific heat capacity. ठीक है. क्वांटिटी ऑफ हीट क्यू पर डिपेंड करेगा. ठीक है. सो मटेरियल ऑफ द बॉडी एक चीज एंड दूसरा ऑब्वियसली क्वांटिटी, मटेरियल क्वांटिटी जो है दैट इज मास. बेसिकली मास एंड स्पेसिफिक हीट दोनों को लेकर के दैट इज कॉल्ड थर्मल कैपेसिटी. दैट इज व्हाट वी आर टॉकिंग अबाउट इन द मटेरियल ऑफ द बॉडी. It's not only a specific heat capacity, rather it is heat capacity. Heat capacity is M into S. That is also called thermal capacity. Heat capacity. MS. ठीक है. So MS पे डिपेंडेंट होता है, Q पर डिपेंडेंट होता है. अच्छा, Q अगर ज्यादा होगा तो डेल्टा T ज्यादा होगा. ठीक है. चेंज इन टेम्परेचर ज्यादा होगा. अगर MS ज्यादा होगा, ठीक है, तो डेल्टा T कम होगा. ठीक है. बात समझ में आ रही है? सेम क्वांटिटी ऑफ हीट अगर सप्लाई करते हैं, दो चीजों के अलग अलग एमएस वैल्यू है, तो डेल्टा टी का वैल्यू क्या होगा? तो डेल्टा टी का वैल्यू कम. राइट. ठीक है. द ओके. Quantity of heat, when heat is imparted or given to the body, its temperature rises, while if heat is rejected from the body, its temperature falls. On heating, the molecules begins to move faster, so the average kinetic energy of the molecules increases, and so the temperature rises. On the other hand, on cooling, the average kinetic energy of molecules decreases, so temperature falls. ठीक है. B. Material of the body. Some material rise to high temperature while some to a low temperature even when same quantity of heat is imparted to them. Reason: different material have different specific heat capacity, that is different amount of heat required to raise the temperature of the unit mass by unit rise in temperature. Specific heat capacity S. ठीक है. S into M is heat capacity. S is called specific heat capacity. ठीक है. S is specific heat capacity. Capacity. ठीक है. और इसका मतलब होता है amount of heat required amount of heat required to raise temperature of unit mass of the body by 1 degree Celsius. ठीक है. Next thing is change in state. Matter exists in three different states, namely solid, liquid, and gas. The process of change from one state to another state at constant temperature is called change of state. Change of state क्या होता है? The process of change from one state to another state at constant temperature. The temperature remains same during the process. When a solid is heated, it changes into liquid at a fixed temperature. This process is called melting. The reverse happens when a liquid is cooled. The liquid freezes into solid at same fixed temperature. This process is called freezing. The reverse happens when a liquid is cooled. The liquid freezes into solid at the same fixed temperature. This process is called freezing. For example, ice at 0 degrees Celsius on heating melts into water at 0 degrees Celsius, while water at 0 degrees Celsius on cooling freezes into ice at 0 degrees Celsius. When a liquid is heated, it changes into vapor or gas at a fixed temperature. When a liquid is heated, it changes into its vapor. The reverse happens when a liquid is cooled. The liquid freezes into solid at same fixed temperature. This process is called freezing. For example, ice at 0 degrees Celsius on heating melts into water at 0 degrees Celsius, while water at 0 degrees Celsius on cooling freezes into ice at 0 degrees Celsius. When liquid is heated, it changes into vapors at fixed temperature. This process is called vaporization or boiling. The reverse happens when vapor is cooled. The vapor condenses into liquid at same fixed temperature. This process is called condensation. For example, water at 100 degrees Celsius on heating vaporizes into steam at 100 degrees Celsius, while steam at 100 degrees Celsius on cooling condenses into water at 100 degrees Celsius. ठीक है? When a solid on heating changes directly into vapor at a fixed temperature, the process is called sublimation. For example, camphor on heating changes directly from solid to vapor. These vapor on cooling changes directly into solid state. ठीक है? This process is called solidification or deposition. गैस से सॉलिड में डायरेक्ट कन्वर्सन है सॉलिडिफिकेशन और डिपोजिशन. सॉलिड से सब्लिमेशन और गैस सॉलिड और डिपोजिशन या सॉलिडिफिकेशन दोनों. The change of state from liquid to gas at all temperatures is called evaporation. At a fixed temperature, gas to vapor conversion is vaporization or boiling. At fixed temperature एक अरे liquid to vapor at a fixed temperature is vaporization or boiling, and at any temperature it is evaporation. Thus, evaporation differs from boiling. Boiling is at a fixed temperature, while evaporation takes place at all temperature. The second difference between them is boiling takes place throughout the bulk, whereas evaporation takes place only at the surface. The surface. Evaporation takes place only at the surface. मतलब vaporization पूरे bulk में, पूरे mass में, हाँ, पूरे mass में. और evaporation सिर्फ only at the surface. ठीक है, ये नोट कर लेते हैं. पहले भी बताया था evaporation, फिर से लिख लेते हैं, takes place only at the surface, whereas boiling, vaporization takes place. हेलो, हाँ क्या बोलिए ना, हाँ मैं भेजता हूँ थोड़ी देर। हाँ
इसमें ये जो क्वेश्चन व्हाट शुड बी आउट द लार्जेस्ट कार्बन मोनोमर वी नीड अ परफेक्ट स्क्वायर सो दैट वी सॉल्व इट परफेक्ट स्क्वायर।
क्या, अच्छी बात है, फिर हम लोग सो जाएंगे,
तो फिर
लिख देंगे कि इट्स अ परफेक्ट स्क्वायर।
वही करना है ना बस।
हाँ अगर परफेक्ट स्क्वायर है तो। अबे है क्या लिस्ट 5 डिजिट नंबर, 5 डिजिट लिखा है 6 डिजिट नंबर है। अबे यार ये तो गलती हो गई, बताइए, ये तो इजी हो गया, इट हैज बीन अ ब्लंडर ऑन माय साइड। उसको 6 डिजिट कर देना,
नहीं सर,
नहीं आप नहीं कर सकता, माय मिस्टेक। थ्रू आउट द मास, ठीक है, वेरी गुड। Evaporation is a slow process while boiling is a rapid process. That is another difference. Evaporation is slow, and boiling is fast. Boiling is fast. ठीक है. Figure 6.1 shows the change in different states of matter: solid to liquid, melting, heat absorbed; liquid to solid, freezing, heat rejected; liquid to gas, vaporization, heat absorbed; gas to liquid, condensation, heat rejected; solidification, gas to solid; sublimation, solid to gas. During the change of state, the heat absorbed or rejected is called latent or hidden heat. Just underline the word latent or hidden heat because it is not manifested by any change in temperature. So the latent heat or hidden heat, because it is not manifested by any change in temperature. Why it is called latent? Because it does not lead to any change in temperature. ठीक है? This heat, when expressed for unit mass of a substance, is called a specific latent heat. Specific latent heat. Specific latent heat का मतलब क्या हुआ? Yes बेटा.
For the third वाला, if you are finding the मतलब हम लोग आंसर से डिफरेंट मेथड में फाइंड आउट कर सकते हैं। मतलब मेरा आंसर एक डिफरेंट मेथड से।
एक सेकंड, मुझे क्वेश्चन दिखा, मुझे क्वेश्चन थोड़ी याद है बेटा।
थोड़ा
तो कैसे भी करो, उससे मुझे फर्क नहीं पड़ता है,
बस आंसर चाहिए ना,
मुझे आंसर दे। 21 नंबर से डिवाइड करेगी और दूसरा चीज उस जो कोसेंट होगा उसका क्यूब रूट क्या, स्पेसिफिक लैटेंट हीट कैसे डिफाइन करते हैं?
तो मतलब हम ऐसे बोलेंगे कि चेंज ऑफ स्टेट ऑक्कर करता है पर टेम्परेचर चेंज नहीं होता.
Amount of heat required to change state of a body, change state of a body.
स्पेसिफिक लैटेंट हीट और लैटेंट हीट अलग है.
Yes. The amount of heat required to change state of a body, heat required / rejected, change state of unit mass of a body, unit mass of a body at a fixed temperature. ठीक है? Very good. Okay. This heat, when expressed for unit mass of a substance, is called specific latent heat. The latent heat, instead of raising the temperature, is utilized to change the force of attraction between the molecules of a substance. इसको underline कर लो. The latent heat, instead of raising temperature, is utilized to change the force of attraction between the molecules of a substance. Since temperature remains constant, इसको underline ही करना है. Since temperature remains constant, the absorbed heat has no effect on the speed or average kinetic energy of the molecules. Thus, during interconversion of state, the latent heat increases or decreases only the average potential energy of the molecules, whereas the average kinetic energy remains unchanged. Is that okay? During interconversion of state, only average kinetic energy of the molecules increases or only average potential energy of particles increases or decreases. The average kinetic energy of the particles remains constant or remains same. ठीक है? Change in size of the body. When a body is heated, it expands, and upon cooling, it contracts. This change in size of the body due to heating is called thermal expansion. Change in size of the body due to heating is called thermal expansion. Generally, all solids, liquids, and gases expand on heating or contract on cooling. Expands and upon cooling it contracts. This change in size of body due to heating is called thermal expansion. Generally, all solids, liquids, and gases expand on heating or contracts on cooling. The reason is that on heating a substance, the average intermolecular separation between the molecules of a substance increases, while on cooling it decreases. Hence, the size changes. ठीक है? इसको underline कर लेंगे. On heating a substance, the average intermolecular separation between the molecules of the substance increases, while on cooling it decreases. ठीक है?
Yes.
Effect of temperature on molecular motion. यहाँ effect of temperature on molecular motion. We have read that molecules of each substance possess kinetic energy by virtue of their continuous motion. When the motion becomes less rapid, the temperature decreases, and when the motion becomes more rapid, the temperature increases. The molecular speed decreases. At high temperature, the molecules are very much agitated. This suggests that as a limit, when the temperature will become zero, the molecular motion ceases. The temperature at which molecular motion completely ceases is known as absolute zero or Kelvin scale. Absolute zero on the Kelvin scale. The temperature lower than absolute zero is not possible. ये underline करो, the temperature at which molecular motion completely ceases is known as absolute zero on Kelvin scale. Is that okay?
Yes.
Very good. यहाँ पे हम लोग आज के लिए रुक जाते हैं. We'll continue from here in the next lecture. और अगली बार थोड़ा जल्दी आ जाए 4:15. ठीक है, बाकियों को भी मैं बोल दूंगा be here by